going to talk about simplifying radicals. There are some square roots you should know based on your multiplication facts. Square root of 1, square root of 4, square root of 9, etc. And this may be the way you're accustomed to seeing those. But what we actually know is the square root of 1 can be 1 or negative 1. Square root of 4 can be 2 or negative 2, etc. Typically, we just list this positive answer unless there's a negative out front indicating they want the negative answer, but it's always good to keep this in mind. So let's look at simplifying a square root that is not a perfect square. If this were the square root of 49, it would be very easy. We get the answer 7, or negative 7, of course. But in this case, 50 does not square root nicely. My first step is going to be to break the 50 down into its factors. So here I've broken 50 down into its factors. 5 times 10. The 10 can be broken down more. The square root of 50 becomes 5 times 5 times 2 under that radical. What I tell my students is it takes 2 of something to be removed from the square root. That is, there are 2 5s under the radical. That becomes 1 5. That becomes 1 5 outside of the radical. The 2 does not pair up, so the 2 is left inside the radical. Another way to think of this is 5 times 5 is 25. The square root of 25 is that 5. The 2 is left underneath. Here we have a much larger radical, 392. I'm going to take that number 392 and I'm going to start by breaking it into some factors. The thing I can see for sure in 392 is it's even. That means a 2 goes in there. After some short calculator work, I get 2 times 196. I'm going to break that 196 down. 196 is even, so there's another 2 in there. I'm going to break the 98 down. 98 is even, so I see another 2 in there. And now I'm going to break that 49 down. This is called prime factorization, and if it's a process that you're unfamiliar with, I advise you to look up another video and make sure you understand. Now that I have this 392 broken down into its prime factors, I can start pulling out the pairs of factors that match. That is, these 2s and these 7s. Notice that the 2 and this 7 both come outside of the radical, and this 2, which was not matched up, stays inside the radical. The numbers that are outside multiply together. The numbers that are inside, which there was only a 2, multiply together. And our final simplification is 14 times the square root of 2. We can also simplify radicals when they contain variables. Square root of 12x cubed. If I break that down into its prime factorization, I could write it out like this. 2 times 2 times 3 times x times x times x. This makes it pretty easy to see that the pair of 2's will come out of the radical, and this pair of x's will come out of the radical. Again, it takes 2 of them inside to make 1 outside. What I get then is a 2 and an x outside of the radical, a 3 and an x left inside of the radical. My final answer is 2x times the square root of 3x. Sometimes there could be a number outside of the radical already. That doesn't affect us. I'm going to leave that 3 outside and break down the 45 under the radical. Next, I notice that these 3's match up. I'm going to pull them outside of the radical, and they'll join this 3 outside. Notice the 5 is left inside the radical. The things inside multiply together. The things outside multiply together. And 9 square root of 5 is my final simplification. Thanks for watching.